Hello, everyone. My name is Surabhi Pokharna, and I'm here to discuss about Snowflake concepts and architecture. A quick intro about me. I am a data professional with 20+ years of experience. In my current role, I am involved with an enterprise-scale cloud data migration in Azure IaaS and PaaS. Along with that, I lead a global cloud data platform services team. I am one of the New England SQL Server user group board member in Boston and one of the DBA virtual user group leader. I have spoken and I do speak in Data Saturdays, user groups, and SQL Bits and PaaS Summit. This is my contact information. Best way to connect with me is please connect me in via LinkedIn and message. So, when we start our Snowflake learning journey, there are various considerations with concepts, architecture, getting into the data, like exactly how to navigate your path with the data, various types of data, and various operations within the data, performance, monitoring, data security, governance, etc., etc. So these are the various considerations you would be doing when you start your journey, learning journey. And in today's session, next 20 minutes, my goal is to cover the first two verticals, get you familiar with the concept, architecture, so that when you go out, you are equipped with that basic knowledge, and you can get going with the next verticals. So what is Snowflake? Snowflake is a fully managed cloud data platform. What does this mean? What is the meaning of fully managed? Fully managed means that you go, it's a web portal, you sign up there, and now all your services would be deployed by the vendor. You pick what you are looking for, what kind of edition, what kind of business model, but underneath you do not have to worry about the deployment. There is no access to the OS or the hardware that has also been deployed by the vendor. No component administration required, so that all the patching, administration, all that routine stuff is also being taken care of, including the rebuild index and update statistics. We'll come to that when the time comes. So this is the part of fully managed cloud. What does this mean in terms of, with respect to Snowflake? Snowflake is cloud agnostic. It can work on Azure, AWS, and Google Cloud. But not only that, you can replicate your data across these various cloud providers in order to maintain the global single source of truth. So that you have a data in Azure, and with the snow grid, so underneath the technical term is called snow grid, with that kind of networking, which is obviously needs to be super safe, secured, you can move your data across various cloud providers. So this is the one feature which makes Snowflake stand out. And that is the fully managed, we understood, cloud. And now what is data platform? So the data platform means you can build your data solutions in Snowflake, whether it is a data warehousing, including the data lake, and then various app development capabilities. Data sharing, that's another feature which makes Snowflake stand out, because in the data sharing, you can share the data with your stakeholders or your clients on a private, secured manner, or you can build your data, like, for example, the COVID data, right? There is a COVID analysis. Now, somebody prepared the data, Johns Hopkins, one research student, and then released that on a public market for everybody to use that. So that is another example where you can have for the data sharing on a marketplace for the public use. So this is another feature from Snowflake which makes it stand out. So now we understood what is fully managed cloud data platform. Moving along. How you want to start, right? Right after this session, I want to play around a little bit. So 30 days, $400 credit, no credit card required. You can sign up from snowflake.com website, and here is the start for free with your one of the email address. Now, when you go there, it would ask you for the editions. What kind of edition you want to pick? By default is Enterprise Edition. There is a standard more for the development purpose, Enterprise, and the business critical. Enterprise, here that understand the first two lines which are written underneath an Enterprise, 90-day time travel. So this time travel, like I understood our audience when you guys raised your hand, most of you guys are SQL Server professional, and I'm also hardcore SQL Server professional from past 20+ years. So as like we do compare, right? Oh, okay, that is how I do backup and restore, so how it is in Snowflake kind of thing. So from that perspective, time travel means with your tables and your database, you can go back up to 90 days and restore any point in time recovery for those individual tables and the database. When you pick Enterprise Edition, you want more high availability features, you want more security, then there's a business critical. Now, during that addition, you make another decision, which choose your cloud provider, Azure, Amazon, or AWS, or the Google Cloud. And during that time, when you pick, let's say I pick Microsoft Azure as my cloud provider, I need not to have a Azure account that time in point in time working. So because underneath, that is all Snowflake would take care of that. So you don't need that account, and that is how you pick, and you pick your addition. Moving towards the architecture side. This is core. We'll spend a few minutes around on this particular slide and understand. So the Snowflake architecture, it consists of key three layers. To begin with, start with the data storage. Data storage means that when you do the data loading in Snowflake, underneath, optimized, compressed, columnar format, data would be stored in the data stores, which is something is not visible to us. It's none of our business to worry about that, how most optimal way we have to store the data. That is taken care of by Snowflake underneath, but that is how data would be stored. Do you have the visibility directly to this layer? No. Can you query? Yes. So you can query those in the data stores and identify work on those tables and underneath what's going on, but how the mechanism, how it would be stored, you do not have to worry about that. The second layer and the mind behind the whole thing is query processing. That's where we do our business. So that's where when we do our business, that means you need compute. So let's take a step back and think about from the SQL Server perspective. What do we need? In an on-prem side, you would have some CPUs, some memory, and then a disk, which disk is a storage, let's not talk about it. Only talk about the CPU and memory. When we translate that into the cloud language, that is called compute. In order to process a query, you need a certain amount of compute. Now, I have a workload where in the morning, I do a lot of data insertion, batch workload. And that needs like maybe 32V CPU and 512 gig of RAM. I'm just talking not even the cloud language, the basic language, right? Now, you need that much amount of compute and that much amount of processing power. But that same time, you have another processing going on, which is doing millions of transactions, where you are looking for the lowest latency. Now, when you are working on Snowflake, you can create these separate compute areas. That you are doing the batch processing for those certain tables. When this query for batch processing execute, go underneath and use this particular virtual warehouse, which is nothing but your compute with a certain amount of processing power it is giving. And I can isolate and create another virtual warehouse, which would be taking care of my transactional workload. So at the same time, based on my requirement, I can basically get multiple computes, and each virtual warehouse, so the name is a bit complicated, like virtual warehouse, right? But it is nothing but the compute or processing power underneath. Each virtual warehouse contains internally MPP, multiple massively parallel processing architecture, and with the multi-node cluster. So each virtual warehouse can grow up to a certain level of multi-node cluster with the parallel processing capabilities, and I can run my business in parallel with the multiple virtual warehouses. Any question on this concept, where if you are able to visualize that, how it is working? Okay, I take that as no. And most of the questions we'll take towards the end. So now it is giving us the capability to create multiple virtual warehouses. But when you start with your free account, you get by default one virtual warehouse attached. And also those virtual warehouses have this capability where you can do the auto pause or auto resume, like a lot of things similar to Azure SQL and Azure SQL hyperscale style. So you can do that auto pause. You are not running that virtual warehouse, or or I run in the morning. I want to grow my, my nodes, virtual warehouse nodes to a certain level when I'm doing the batch workload, and I want to come back and shrink that, but I'm doing the trading or the transactional processing throughout the day, so it would go to the separate virtual warehouse. So this is all the mind. Then comes the cloud services. Cloud services is a layer which is managed by Snowflake. But when you sign up for the Snowflake services via their web portal, and we will browse through the web portal real quick, you get two databases created by default. One is the database, like a sample database, and one is the Snowflake database. That Snowflake database contains all this information about your metadata, about your auditing capabilities, what kind of work you are doing. And when you start query processing, it goes through first, oh, are you like authorized to work? So it would authenticate you. All the security layer would come into the picture, and metadata, which would see how the statistics are. Do we need to maintain the statistics? Optimizer will generate the certain execution plan internally. And then infrastructure manager would manage your all that, which virtual warehouse you have to go. All that is managed by Snowflake. We have the views. We can run those view queries against those views to see how things are happening, but we do not have to do that. So the optimizer is doing its job. Security is taking care of authentication. All that cloud services is managed by Snowflake, and your cost model, you would be paying money for all the processing, which you are doing in the middle layer, query processing. You would be paying for the storage. And you would be paying for the data movements, because of what amount of data you generate and it moves over the wire. But you would not be paying for the cloud services which you are getting, and for that one Snowflake database by default which you are getting. So that comes with as part of services. And underneath the actual storage, it depends like how much storage you would be using. So this is the core, which gives you about the view of these 3 layers. So real quick, we already discussed virtual warehouse is an MPP, parallel processing database engine, decoupled storage and compute, so that you need 10 GB storage, but you need very large virtual warehouses to support your compute or the workload and the processing power, you can do, or the vice versa. And integration with cloud storage is seamless. That is how it is talking to cloud storage. In the previous diagram, we saw those layers. Virtual warehouse operations, so now we saw, right, what do you need to pay money for, or what kind of processing? So within the virtual warehouses, you are selecting a lot of data, executing your reports, processing your data loading, insert, update, delete, or the copy. So for those are the operations you would be paying money for. You do the select from your all that view in the Snowflake database for all your security roles, users, and all that. You're not paying money for that. In nutshell, virtual warehouse sizes, there are various sizes. You can configure nodes, and accordingly, there are credits or the money. Accordingly, it would be deducted. And you can grow dynamically as and when required, or you can auto-pause or auto-resume. OK, so now this is so we got a fair idea about the concept, about the architecture piece. Now, when you log into Snowflake, now you created your free account, you are in that 30 days happy period with $400 credit, and you log in with your account. What do you see? So you see there is a web portal with the various capabilities. It is like a single-stop shop to do all kind of data solutions, building or browsing and checking around those things. Within 20 minutes, we might not be able to go through every piece, but like as I mentioned, in the database, by default, you get 2 databases, Snowflake and Snowflake sample data. Sample data is already filled with certain type of data, and Snowflake is the one which is in that cloud services layer. Remember the first layer? That's where actually it is storing all the metadata, query performance, and giving you, or like auditing details, and giving you everything. So by default, database level, table level changes of auditing, etc. is also enabled. Now, another area, which something you would be working a lot, or you would like it, so worksheet. There's in the projects, there's another column which is worksheet. Worksheet gives you, it is like a Azure Data Studio, where you can have your queries, and also it gives you the query window, which is like an SSMS or Data Studio, where it is maintaining the version, and you can execute your queries. Also, you can save your version-controlled scripts here forever. Like these are the presentations which I keep changing. Some of the scripts, the tutorials, you get Snowflake by default, and since I come from AnySQL Boston, so I have my AnySQL, those scripts, which I would be reusing and all that. So there are multiple versions, which internally Snowflake takes care of saving that. Table structure. This is important concept. So within the table structure, how the data we see as a table, you do your select star and all that, fair enough. Underneath, it creates micro-partition. From the layman's language, data is stored in data pages, and each page just assume that as if this is a micro-partition. So now, each page, when there is a micro-partition, there are 10 pages, there are 10 micro-partition. One of the very cool concept comes with the cloning of tables. So with the cloning of tables, so this is something like, just to give you the fair, very high-level idea, that is how the logical structure is. And internally, when tables are in micro-partitioned or columnar format, we already discussed, right? The stored and optimized, compressed. You might not see that kind of thing, but the storage layer, that is how it is stored, and there are micro-partitions. So one of the cool concept here is clone table. Clone table, like let's think about from our Snowflake, from SQL Server perspective, we have a table of 5 terabyte. We are doing some troubleshooting, and then somebody says, can I get a copy of this table? I might be changing data here and there just to test this scenario. So now you need another piece of storage to have that big fat 5 terabyte of clone copy of the table, and then somebody would be making changes, but how to integrate and incorporate those changes, you would know that. So in that case, think about that table employee metadata, E1, E2, E3, 3 micro-partition, MP1, MP2, MP3. I cloned the table, which is a logical pointer to the original table. You never need another 5 terabyte to store that additional clone table. Your clone table is also logically pointing to the same table because those are the micro-partition. But now you make some changes in that table, in that cloned table. That would create logically a different micro-partition, and the changes would be in a separate micro-partition. Later on, when you try to just join all those changes back in the master table, that's a separate process. But so in this session, I'm touching base on that very high level couple of concepts. This is one of the concepts which actually makes Snowflake very helpful tool for all these troubleshootings without spending money or time or any of these things. So there is one, this is called the clone table. Moving along, right, so how would you create the database? Pretty simple, you create the database sample DW, and the result, it is the query window where the same arrow key here, the right arrow key, yeah, and my right arrow key, which is the execute, and then that is how the database would be created. When you create the database, you can create so that is how, right, in the web portal, earlier we had Snowflake sample data, now we have Snowflake sample DW also we created. Now we created one table. You have option to create each table into different virtual warehouses. Maybe this is my key data landing or the loading table, and I might create in a different virtual warehouse, and that kind of operation also you can do. But now, by mistake, somebody from my team dropped that table. So when you drop the table, remember we saw that time travel up to 90 days. So by default, every database with Enterprise Edition is coming with that 1-day time travel, means the data, it is retaining up to 1 day, and I can immediately go and click on that undrop table command. But the good thing is, all the syntax is like SQL Server, T-SQL, so that sounds very familiar. And you can undrop the table, and with that undrop, you get all the data back, because within the time travel, there is no backup restore required here. You have that data, whatever time you can set. There is a command show table, and you can set the 3 tables should retain data for 90 days. 5 tables should retain the data for 3 days. 1 table, by default, 1 day is OK, I don't care about that. So like that, you can set those time travel for your individual objects, and you can click and undrop and retrieve the data accordingly. So this was undrop. Access control, by default, you get your certain type of accounts or the roles. I am account admin. And when I'm account admin means that this is my account. When I log in, I create it. This is my area. So this is like a super user. Let's go further, all the way one up from the sysadmin. This is more, the sysadmin is not like SQL Server. SQL Server account admin is like SQL Server sysadmin. And the role with sysadmin here in Snowflake is like that particular role has full access to the virtual warehouse. So all the query processing layer, this particular sysadmin role can have full control. Org admin is your CFO. If you have 20,000 or 20 accounts running, all the Snowflake accounts, somebody is managing from the top, that is org admin. And so this is the glimpse of the security, how it is working. So quick recap. We went through the layer with the introduction and architecture. You got fair idea what is Snowflake, additions, web portal, data processing, and virtual warehouse. And you are ready to go out and create your account with free 30 days, $400, and navigate the next layers. So thank you so much. We landed on time. And here is the feedback. Please fill feedback, and 20 minutes.